Okay, well, let's start and talk about wiring today. So right here we have a basic wiring diagram of how bike lights are actually wired. This is really pretty normal on motorcycles. It's pretty normal, believe it or not, I'm going to explain it on houses and just about everything too. Everything kind of correlates on how this works with electrical. So I'm going to wait for my picture to change here a second. Okay, so first what we have here is we have positive energy from the positive side of the battery, and that is going to go through a wire. Most likely on an automotive application, it's going to go through a fuse, which is where this line stops currently. After it goes into a fuse, it will then either continue on to a light, or it can go into a relay, depending on how high a voltage it actually needs in order to actually light up a light. The ones displayed here on this wiring diagram, courtesy of PhotoBucket, are LEDs, so they don't take high voltage. I will explain how relays work here in a little bit. So after a relay, or if it just continues on, we have the positive side of the battery, the positive side of the energy, then going out to the lights. This then completes one half of our circuit. Now the second half of the circuit is actually quite a bit easier. Most of the time, batteries on vehicles ground directly to the frame, and they do on motorcycles as well. So the battery will ground to the frame or into a fuse block. Most fuse blocks for motorcycles will also have a ground side or just an in and out side. Aftermarket fuse blocks like the one I got do have a ground side as well, which is really nice. But to complete the circuit on the lights, then the negative side of the battery then goes to the either the frame or the lights. I have it shown as the lights here, and this then completes the circuit, then turning on the lights. This, however, does create a small problem, though. So as you can see, I've actually taken off part of the highlighted wiring. So what problem this creates is it makes it so that the lights are going to be on literally all the time. Now, to make it so that the lights are not on all the time, what we're going to do is we removed the wiring that goes to the lights right now. And what we're going to do is we somehow have to interrupt that connection so that the lights go on and off. This can be done with a key or a switch. In this case, we have a light switch on there. That is going to act as our interruption between them. So as you can see in the next thing that I have highlighted, from the relay we now have the positive energy going to the switch, and this is going to be where our connection is interrupted. So in this one, you can now see that we have power going from the opposite side of the switch now out to the lights, which then makes it so that way lights can be turned on and off. This switch can also, in different configurations, go from low beam to high beam, but this is how a basic switch and basic wiring actually works. So I'm actually going to show you now a picture of a switch and show you exactly how it actually functions. So getting into what a switch is, this is about as simple of a diagram as possible. You have your power supply, you have wires coming off your power supply, one going to a light, and then you have an open circuit, which is why you see the circuit not connected. Now you can see we have closed the circuit, which then completes it and makes the light turn on. Next thing we're going to talk about real quick is going to be relays and how those function. There are a couple different type of relays. We're gonna do, I think, two of them. Now, if you've ever taken an actual close look at a relay, you've probably seen scribbling like this printed on the side of it, and you probably have absolutely no idea what it means. So today I'm going to explain how these actually work. Now, you can see the numbers on it: 87, 85, 86, and 30. These are referring to the pins that are actually in your relay that do different things. Now, the first two pins that we're going to take a look at here are going to be 86 and 85. These are going to be the ones that go to a, say, dash-mounted switch. These are going to have low voltage power, and they are going to complete a circuit inside the relay so that high power can then flow through them, which is going to be pins 87 and 30 that I will highlight now. Pins 87 and 30 are what are going to be carrying high voltage in and out. Now, depending on the setup, it could be 87 or 30. It doesn't really matter with that one which one goes in and which one goes out. With this diagram, it is pin 87. So, when 86 and 85 are connected via a switch through low voltage, 87 then is able to go to 30. 86 and 85 complete the circuit between 87 and 30, then allowing high voltage electricity to actually flow through.
Bend in the, there we go. The original bend in the throttle cable from the bike just made it shiny. It looks a little bit better, so. Turn off that a minute. Okay, so got all the stuff for the throttle cable here. And the reason I want to hook this up next is just so I can clean up the bar right here. And you know, get that part sorted out and kind of to a more finished state. So in this universal kit, there is a sticker. Don't know whether we're going to use that or not. There is some end pieces. The cable sleeve, which is the black part that you see, and then the cable itself. So the reason that nothing I had would really work is because this one has a tiny little, basically a ball on the end of it that goes in here and actually keeps it where it's supposed to be at. Nothing I had really worked for that. So there just wasn't much that I could do in the way of making sure that it did what it was supposed to do. So I didn't have a way to modify anything at the time. I'm going to need to take that back out. I know a lot of what I'm doing right now is probably not, you know, glamorous. You know, this is kind of the butt end of the build. So for me, it's fun. I enjoy, you know, this portion of it because, you know, this is the final stretch. This is where you get to see stuff come together. You know, it's cool for me. I like it. So I apologize to anybody else if you don't like it. You know, I am sorry. But if you don't like it, then go watch Bikes and Beards. The Bearded Mechanic. He's got a little bit nicer voice than I do, and his stuff just kind of works most of the time. My stuff just kind of maybe works and falls together sometimes. So If you do go over to his channel, though, have him give me a holler, on there, a shout out. I have no idea what I'm doing. I've never built a throttle cable before like this, so I have absolutely no clue what I'm doing at the moment. So you get to watch me fail. We do dumb stuff like this for funsies because we don't want something. Yeah, there we go. There's an end. All right. So that's back on there. And this we're going to route through the literal same hole as we're going to do the wiring. So that way we can try and keep everything literally as hidden as possible. I want one wire showing down here, and that's the one for the ignition coil, the one that goes to the plug itself. Just because it's made out of China part.
China!
This doesn't mean I can't try and make it look nice. Now it does kind of look like I'm going to have to shorten this a bit. I wonder if I put this through here if it'll work any better. Yeah, and then I can put the 90 on it, which is in my lap. Okay. So that sits there, that sits there-ish. So I actually want to cut this. Right around here. And I do not want to use an angle grinder on this, however much faster that would be, because I do not want to slice this cable at all. And I really don't want to take it all back out. Which leaves me with burning alive next to this thing, which is still hot. Oh my gosh. Okay, so I don't have a choice. So we're going to take this cable back out of it. And then I will grab the angle grinder and slice that off there. Or can I just do it with this? I can't. It does not make a very good end. So I'm going to grab the angle grinder and actually slice that properly. Kind of smells like ham in here. Must be me. Alright, safety squints, engage. Plug the camera back in. You charging? Yeah, you're charging. And we're still recording, so that's good. Ugh. My ankles still don't like to bend the greatest. So I have a little bit of trouble with that. That's alright though. Progress is progress. And we shan't complain. I am, however, going to complain about wherever the heck that rubber boot went. So we're going to take this other rubber boot out of here now and hope that we don't screw up again. Okay, so there's that. Oh, it's still on the... It's... Okay, so yeah. Come here. If you can't tell, I'm having issues. Well, I am. Okay, so that goes through there. In comes the spring. And that goes on that side. Spring sits down in there. That sits down in there. That slides down in as such. And screws back onto that. So that way when you pull on the throttle, it opens. Okay. So now we're going to take the rest of our throttle cable and we're going to feed it right back through this. I apparently don't have the other problem as most other guys of not finding the hole. Apparently I am able to. Can you see?
enjoyed what you've seen in this video, or found it educational, please hit the subscribe button, like, and leave a comment. Let us know anything that we can improve, and have a great rest of your day. By the way, Happy Easter!